Position. Good morning and good afternoon, everyone, wherever you are. Welcome to today's DTC Asia webinar on developing an artificial intelligence strategy for manufacturing. I am Rajkumar, and me along with my colleague Bob, Leena, and Saurabh are honored to be your host as we explore how AI is transforming the manufacturing landscape and how organizations can strategically harness its potential. We are honored to have with us Mr. Esteban Rebec, CIO, VP Information Technology and Digital, ESP Maxion and Maxion Wheels, who will share his knowledge, practical insights, and real-world experiences. So we'll come to the agenda, where this agenda will run after this presentation. My colleague, Mr. Bob Gill, will introduce the session and the speaker. Also, he will do the topic introduction. After that, we'll have a panel discussion along with our speaker and Bob Gill. And I'll request all the delegates to put your Q&A in the Q&A box only. We'll address all of them during the Q&A session at the end. Thank you for joining us today. Without further delay, let me hand over to my colleague Bob Gill for the topic introduction. Over to you, Bob.
Thank you, Rajkumar, for that introduction. I do think it's worth emphasizing that these Digital Transformation Council Asia webinars, which are now well into their 5th year, they're all about learning and sharing. And we do this by inviting industrial practitioners who are digitizing and transforming their facilities and their organizations to come and tell us their story and to engage with you, our audience. But you may also have wondered, especially those of you who've been with us for a long time and seen many of these webinars over the last few years, you may have wondered what's happened to those companies and their initiatives that we've been featuring. So I am happy to say that for the first time ever, we have a second-time guest speaker, someone who was with us way back in February 2021 and is returning today to continue his story. I think this is something that's really important because if you recall, at the start of this decade, 4 or 5 years ago, there was a huge buzz about digital transformation. You saw technology suppliers evolving or recreating their automation and software solutions around this objective. And you had industrial end users feeling that they had to get onto this transformation road quickly or risk getting left behind. But it's also true that many digital transformation efforts did not always achieve the desired results. So you had that initial burst of enthusiasm resulting in some successful pilots and projects, but not in something scalable across the organization, or I think especially something that could be sustained over several years of the necessary investment and C-level executive attention that you need for digital transformation. Here at ARC Advisory Group, we have identified several key skills that companies need to have and to develop to enable successful transformation. These include things like the ability to master and deploy new technologies, to be able to imagine and reimagine a future state where those technologies translate to competitive excellence, to empower the organization such that decision-making is now supported by relevant and accurate data, and to lead the organization along the journey in the face of what will be inevitable challenges and setbacks along this road. So, as I said, back in 2021, Esteban Rebec, CIO and VP IT and Digital at Maxion and Maxion Wheels, presented on driving digital transformation. And today he will be speaking about Maxion's advanced digital transformation and AI manufacturing strategy 2025. AI drives new directions for business growth. So after more than 4 years, Esteban, it's a real pleasure to welcome you back to ARC's DTC Asia webinar. And over to you.
Bob, team, hi everybody. Very happy to be here. Very happy also to have the second opportunity to share in our journey and what we have moved from, as Bob says, technically from 2020, but of course in this arena, in this forum, together with ARC Advisory from 2021. Our journey actually started in 2018 with our committee and the CEO drive and focus on initiating the digital transformation. And this is when I joined Joshpe Maxion and the Maxion Group. And I was charged with this fantastic journey of addressing productivity, ROI-based digital transformation. So very happy to share with you our journey. And of course, as Bob was mentioning, we had this big buzz at the beginning of the decade where everybody said, okay, digital transformation, if you're not doing it, you're missing out. And yet not many companies have had a scalable success, a scalable, tangible success into digitally transforming the way they do the business. Now, what we will discuss today, what we're sharing with you today is industrial AI, based on analytical AI. We hear a lot about the buzz of generative AI that it's creating, which is in a way also giving a wind to the sails of adoption of AI, but not very often it's addressed on its specific field on analytical AI. So what we will focus on our today's chat is on how we're doing AI in manufacturing in the shop floor. So without further ado, let me get started with the presentation. I'll try to rush through it so that I can then sit together and discuss some topics in the Q&A if there's any points we want to address from what we have seen. Okay? Lina, Bob, if you allow me to share my content, I'm about to jump in. Is that okay?
Yes, you can go ahead.
Great. Guys, can you see the presentation? Just want to make sure if
Yes,
we're all
yes.
here.
Yeah.
Great. Then let's get started. So, of course, the goal of doing AI is to drive business growth, to improve the way we're doing business, to improve our productivity, analyze our processes. And this is the goal of this presentation. We'll look briefly at what Maxion is so that we put the context of the industry and what we're addressing in our operations. We'll share with you a little bit about what it is to have the digital transformation at Maxion and what our focus in it is and how we have built this industrial AI platform. And as it is mostly the case, we'll introduce the platform in a demo. You can see when I say a demo, it's not like a mock-up of the platform, but we'll see the real platform in operation. This is the Scalable Industrial AI platform that we have built together with our partners. And then we will have, of course, this opportunity for Q&As. So let's get started. Brief introduction about Maxion. What are we? So we are the largest wheel and structural component manufacturers in the world. We have 32 operations, 17,000 employees in 14 countries. And this is important to address. We are in geographically distributed location across the world that try to address our market demands within our customers. This is a brief overview of the products that we make. So you can see chassis components and structural components, especially for light and commercial vehicles in our structural components division. And at the bottom, we can see the wheels that we make. And that means from forklifts to John Deere's wheels in agro, everything that goes with their commercial vehicles, trailers, automobiles, anything that goes on wheels, we address. So we make about 50 million wheels a year, that between steel and aluminum. So it's very likely that if you have a car, that car is running on our wheels. The geographical distribution that you can see goes from Asia, far in Japan, all the way to South America, in Argentina, and of course, North America, the US, and continental Europe. So what is our DT focus at Maxion? What do we want to do with digital transformation? You know, many companies said, hey, you need to jump into it, you need to do it, but we needed to have an objective with what we wanted to address with digital transformation. And that meant solving real business cases, improve our financial results, help us become and stay as a market leader to better serve our customers whilst being sustainable, because as you know, sustainability now is at the call of the day, and it's a very important value proposition of manufacturing towards our own commitment of sustainability and towards the support of our customers' journey in sustainability. At the same time, it will help us integrate business functions and businesses themselves. Digital transformation cannot be done without people. And for that, we needed to create new competencies or help our people to develop those competencies. So reskilling in these new technologies, but that happens mostly when you can attribute ownership mentality and the smart use of time. That means without disrupting the existing operations, reskilling, retraining our people, our employees, and allowing them then to utilize those competencies effectively as part of their jobs. And of course, also create global thinking with local actions. So we will see this a little bit further. It meant when we're trying to address a challenge with technology, we immediately start thinking, how likely are we to scale that technology? Is it a local for local, local for region, or local for global solution that we're addressing here? So we don't do technology for the sake of technology. We want to deliver measurable value driven by people with scalable digital transformation solutions. We all know resources are limited, heterogeneous environments, and that means we need to address those challenges in an orchestrated way with also reliable partners that can help us accelerate and reduce impact of this diversity and heterogeneous. Each proven plan scaled solution then creates a global scalable roadmap. That means we might start with a POV, but we always have a scalability journey within building, meaning if we do this, can we scale it up? If not, what else can we do that is truly scalable so that we can copy, paste? And this is the logic behind our journey in digital transformation, and also with the use of artificial intelligence. Our value proposition, data is the key. We know that. I'm pretty sure everybody remembers when everybody was talking about data is the new gold, and it is, if we can use it properly, or data is the new oil, more or less the same, is the acceleration of digital transformation through development and easy deployable and scalable enterprise industrial AI service-oriented solutions. So we have at one side data structured, coming from different places, that is not telling a lot if we don't put semantics behind it. And what we want to do with that data is bring it from what it is to what we want it to be. A complete new value proposition based on what that data is able to tell us. So from unstructured data to AI-driven value based on that data, right? The challenges. We are a manufacturing company, we have 33 locations, and we also come from a legacy where mergers and acquisitions took place. So we have heterogeneous operations where equipment is, in some cases, 30, 40 years old. In some cases, there's new equipment in the shop floor. We are about to launch our plant in Turkey for commercial vehicles, aluminum wheels, light wheels for trailers. And of course, that's new equipment, new connectivity. We plan it right from the beginning. Whereas in other of our operations, in Sedalia, in Arkansas, in other places, these are operations that have been running for the last 60 years. As a matter of fact, Maxion, Maxion, the company is over 100 years old. It was doing other trades in businesses and entered in automotive about 60 years ago, and bought other operations from other companies. Therefore, there is a heterogeneous landscape. And that is one of the major challenges. I'm pretty sure that if you're listening, you can identify yourself with this as an industrial operation. We have, of course, legacy machines. We cannot always trust the data. There is cultural and language barriers. As we showed, we're in 14 different countries. So to communicate, especially in the shop floor, is not always that easy as it will be with engineers across the organization or IT across the organization. Resources are always a challenge because they're already working on operation on projects. Domain specialists that we can collaborate with, that can share not the technology-based solutions, but the expertise on the processes that can, with the combination of those technologies, deliver value. It's also a challenge. Of course, data talents and resources in CapEx or OpEx are always in competition. What value would we bring out of this if we were successful? We could reduce our energy and utilities consumption. That brings down our bills in manufacturing. At the same time, it reduces our CO2 footprint. Then sustainability with savings in our operations come together. The process and product design stability and optimization. When you cannot improve what you cannot measure, right? So having the possibility of identifying the right process parameters to improve your process and your manufacturing is critical for you to become operationally efficient, right? And this is what we want to address. At the same time, in the back office, in the functions, if you can provide the data about what you're doing, your manufacturing, where you are, then you can take better decisions in how to address challenges if you're having them. Cycle time optimization. That means reducing your time to produce, productivity increase, and cost savings and profitability. So this is one of the goals as well. If we can then apply AI and machine learning to optimize the quality of our processes and our product, that means less waste and at the same time savings and cost reductions in manufacturing. So data-driven decisions multiply also the intrinsic specialist know-how. What does that mean? If we can create a digital twin of our processes, that means that we have absorbed the know-how of our domain specialists in a way that we can replicate it as well. And this is a direct benefit of going through this journey as well. That means we create again value from data to optimize our processes. Just to give you a bit of a snapshot of how our operations look, you can see on the top left one of our aluminum operations, casting machines. They're very heavily industrial operations, right? You could see to have network connectivity and collect data from this kind of environments would always be a challenge. You can see also on the right side, the raw material warehouse. It's all heavily steel structures with a lot of obstacles. And in the bottom, you can see that sensors in these equipments are not readily available. So this is some of the challenges that I imagine many of you might have to address or have addressed already. Definitely that was one of the challenges that we needed to address in order to enable data, collection of data, which is at the foundation of value from data. So having said that, a brief summary on how we addressed this journey. As I mentioned at the beginning, in 2018, we launched the DT program. Bob, if you remember, we shared that we wanted to launch this in Singapore in an event where we met and introduced this journey. Then we created an internal DT readiness assessment. Think back 2018, 2019, there were no tools that anybody could really utilize to say, okay, how ready am I to adopt the journey in digital transformation? So we went and did a due diligence of what it is that we needed to measure and qualify in such a way that we could understand where we are and where we wanted to be. So we created this internal benchmark and external benchmark, collecting data from the outside, what it meant to have shop floor connectivity, data collection capabilities, sensor and PLC standards, SCADA and MES. So we created this due diligence and we gave ourselves a score. Based on that score, we started creating targets on where we wanted to be. And every year we continue to do that for our whole operation, because that helps to give visibility on where we are and the gap on where we want to be. So in our AOP cycles, on our business plans, we're able to address those items that would improve our readiness for DT. We couldn't do it across the whole operation in one go and one shot, as you can imagine. So we started doing it in the operations that were more ready, and at the same time in different cycles started to build up the capabilities in those operations which needed to have attention. We did an MES RFP, so we collected the requirement specifications of what we wanted to have and needed to have in our operations and went out to the market. So request for proposal, a tender if you want, and collected the right information and made a decision. We did the same for our SCADA. We needed to have a solution that was fit to our purpose, that was meeting our requirements. We did that and we decided for a solution. We built up a data analytics service center because we needed to understand what is necessary to do analysis on the data that we were to be collecting. And we created what we called at that time a service center, meaning for the requirements, collecting them and addressing them as a shared service, if you want. Then we continued to analyze the capability of our equipment to produce data and to transmit that data to an edge compute solution that will then transmit that to the cloud, right? So the catch here is the equipment, as I mentioned, was not ready. Much of it needed to be retrofitted to collect that data, to have a SCADA system that could identify and visualize that data and could share it also with the edge, which will then collect it. We would tag it out of the PLCs in the right way and could stream it to the cloud. And this is what we did, continue to do, to be quite honest, in our operations. And at the same time, that SCADA solution that we decided was a native platform, but we needed to develop proprietary solutions so that we could scale it also copy-paste based with best practices within our operation. So once we decided for the SCADA solution, we began templatizing it to deploy it and scale it in our operations. And finally, once we had addressed the technology ecosystem and were able to collect data in the way we needed to have it, we started addressing it and streaming it to the cloud, where we started to build templatized analytic models with a third party. We will see in a minute a demo of that platform and our platform made to purpose on how we can replicate the solutions on AI that we have built. And AWS, I'm pretty sure you're in a similar situation. We're a multi-cloud customer. but from the cloud solutions that we understand are available in the market. AWS, I would say, is the more advanced in understanding analytics and addressing operations requirements to enable digital transformation. I know that Microsoft is trying to catch up, and definitely Google is also trying to catch up. But in this special aspect, I do believe that AWS is a leader. And we partnered with them, okay? Now let's go into the specifics of the technology that we will present in a minute. In our case, every process, every product that we manufacture has a lot of intrinsic variables that determine if the product is going to be an okay or a non-okay product. And that could be process parameters, human parameters, environment parameters, and material parameters. And each one of those domains has several variables, dozens in some cases, more in others, that impact, that affect whether that process is going to give us an okay product or not, right? So analyzing the correlation of all those processes into the correct outcome is a challenge. We have, of course, engineers, process engineers, design engineers, shop floor engineers that all collaborate and are very aware of what is necessary to, in, for example, one of our casting machines, based on the molds, based on the design, cast a wheel that is an okay wheel. Very often, however, that wheel, even though all considerations given, is a no okay wheel and becomes what we call scrap, waste, right? That we call then primary waste. Now, to cast a wheel, and this is very common in the casting industry, you produce what is called a recipe. A recipe is same as when we think of baking a cake or cooking a dish. It's a set of parameters and procedures that, if you follow correctly, will give you the outcome, right? So if we're baking a cake, you have your materials and you have your oven and you have your mix. So you mix your materials in the, or ingredients, if you want, in the right way, in the right sequence, and then you put them in the oven for the right temperature, for the right time, and at the end you have your cake. So it's a recipe. It's not different in casting a wheel, for example, in our aluminum operations. Means, okay, we have that machine, you could call that an oven, you set the right parameters, you have your mold. Yeah, when you bake your cake, you also put it in a form, and then you put the materials in, you close the machine, you close it for a specific time at a specific temperature, and then if you did everything right, when the machine produces that raw wheel, you pass it through an X-ray, which validates whether that wheel has porosity or not, whereas there is elongations or deformations. And if all the checks are okay, you have an okay wheel. That means your recipe is working properly. Sometimes, however, there is variables that might change the outcome. Could be temperature fluctuations. Could be that the machine was open too long before you put the next wheel in. Could be that the humidity in the environment had an impact. And this correlation between variables is very difficult to immediately identify. There is clear algorithms that say, if this is the case, then address this point. But this is where machine learning is an advantage over this empirical knowledge. Why? Because the combination of all those variables are 2.4 trillion combinations possible. And to identify which one is the most relevant that you want to address in a fastest way is not an easy task. So with the aid of AI, we are able to identify the 19, say 20 most impactful variables and address them directly, correlate to a positive outcome. And that means we reduce the energy that we consume in making the product, and we reduce the waste on the manufacturing side. So this is where we really begin to see the benefit of using machine learning on data in process in manufacturing. In some cases, we reduce the waste up to 50%, which is fantastic, right? Now you need to think about this. Primary step, you bake your wheel, you cast your wheel, you go to your X-ray, and the X-ray says, this is a good wheel, let's pass it through downstream in the value stream. If you do a good wheel, that means that all the value add that you will do in the next processes, machining, heat treatment, painting, the burring, all this will be positive. If the wheel is not a good wheel, then you can either scrap it immediately, therefore you don't add all these other value processes. And that means if you can improve the number of good wheels, you reduce your actual waste, energy consumption, and you increase your value throughput on that manufacturing process. And this is exactly what we want to do with artificial intelligence. So AI truly resolves the combinations and permutations of relevant influential variables, which otherwise, with even engineers and specialists, we're always working overtime to try to compensate in specific situations. How do we do that? Just a summary. You have your casting machine, you collect your data, and in this case, you can see also here your X-ray. And let me just put here, give me a second. Yeah. You see here the X-ray that is coming out. You see the data parameters of the recipe. Then you do data engineering, meaning you create syntax to that data to make it understandable. Then you put the machine learning algorithm, you evaluate the output, and then you have the optimized recipe saying, please change your process settings to this optimized settings so that you will have only good product coming out of it. And that requires change management for the team in the operations to understand this technology and how to properly utilize this technology. Of course, needs to have data collection capabilities. That means shop floor connectivity, the domain knowledge, meaning the shop floor engineer, process engineer, understanding what the AI is producing, also analyzing what impact that might have and why is that impact. Of course, partnerships with either the partners that help you build your shop floor connectivity, your MES systems, your SCADA system, and the leadership focus on making that possible as well, right? Believing in it, driving it. A simple example where humans analyze specific points, and that is done in post-process. AI can analyze up to 800 data points per second in real time, which is a feat that humans cannot do. On the left side here, we see a metadata that's produced from the process. You have also the machine data and your quality results. You marry all this data, and then you pass it through a platform in analytics by qualifying which data is relevant. You link it to a timestamp. You have your batch ID, your traceability, meaning that product had this data when it was built. And then once you have your outcome, you evaluate your quality results, and you follow up on that in such a way that you say, okay, I have identified all the points. I know the product was okay or not okay. Let's use that data to do analytics. And this is a dashboard, a snapshot from what we're going to see very shortly in the live demo of the presentation. On top, we can see how many products have been produced, what is the schedule on those. So if we're talking of a batch of 60,000, how many have been produced from those 60,000? And you can also in real time evaluate what has been the savings by reducing the scrap that the platform can give us by optimizing the parameters in the production. On the top right here, we can see that there is a boundary set when we see that the process itself is going beyond the prescribed parameters that it should be given or it should run through. And in that, alerts the operator, and after a certain threshold, alerts the shift supervisor to say, we have an issue here, please come and address it ASAP. That means interactively, the platform is talking to the domain experts to say, please come here, we need to address something. Here at the bottom, We can see also the actual OEE of the equipment. That means how productive we're being by having this on board. And finally, here at the bottom right, we can see every little dot that we see over here is a wheel that's being produced with specific parameters that we can track and identify. We see that the parameters around here produce the good wheels that have been true and have gone through the whole value chain. So the machine analyzes that and adjusts and prescribes the parameters that need to be utilized to ensure that we only get good wheels in this case. And this is what we see here on the middle, right? Saying this is the golden batch. When we use the parameters in this area, we get good wheels. And then you compare the scatter diagram of those golden batch with the original one, and you can see that this overlay is giving us the answer that we're looking for, which is the set parameters for that process, for that product, to give us a positive outcome and avoid, which is what we see here on the right, those ones that are not okay or waste. Okay, and this is when we have this, and this is very important to say, and this is the scalability. When we have a casting machine in one operation, we can create a digital twin of that machine. We know the parameters that we need to collect in such a way that we create the analytics, and that is already in the platform. So if I'm in our operations in Thailand, in Saraburi, and I have collected those parameters of that equipment, then I have created a digital twin of that equipment. If I go to our operations in Limeira in Brazil, I don't need to recreate that equipment. I just need to collect the right parameters from that equipment so that I can begin doing my analysis on the data set points that that equipment is actually producing. And that allows this scalability. Now you need to think in any one of our operations, we have something around 30 to 40, 50 casting sets, right? So starting from one single unit, we can say, okay, copy, paste, copy, paste, copy, paste. We just need to collect the data, of course, enable the equipment to collect that data. And instead of analyzing each one of those equipments and trying to set them individually, we can templatize them in such a way that we say, okay, now I need the data from that one there. We're going to have a high runner there. That means I need to have, or a complex product there. I need to have an analytics on that one. And that's the scalability of that. In the past, for each one of those analyses, we would take 6 months. With this, we take 3, maybe 4 weeks maximum to do so. Another example is on using analytics and machine learning to optimize energy and utility savings. What we see here is a real example of one of our equipments, where you can see also here in the first line the number of wheels that were produced at a given power in kilowatts and consumption, right? So we started analyzing what was going on there, and that was the baseline. And then we said, hang on, let's go about checking the heater elements and the power consumed. So why were we consuming that much power per wheel there? And then we realized that the heater elements were going to end of life. So we replaced them and we calibrated the PID control. And then we ran another batch again, and it moved from this red curve to this golden curve in the middle. And we see that we were starting from a kilowatt consumption at this point, and then we dropped 62% consumption in the energy, which was a great saving. If you guys remember when the war in Ukraine started, the energy and utility consumption cost is spiked enormously, right? And that made huge savings. Then we did another round of analysis and algorithm, and we said, okay, can we optimize on that? And we recalibrated the system, and we were able to again save about 40% in energy and utility consumptions without impacting the outcome of the product. Finally, in the last round, it was a marginal improvement, but if you can see how much we're consuming per wheel at the beginning and how much we're consuming now per wheel without impacting the production, you can see here the progression of that analysis and outcome. The catch here is each one of those wheels is saving that saving, right? And again, you can utilize and reuse that same logic across the whole organization. And this is the magic behind the scalability, right? Having it into one single operation is one thing. Having it across the organization is completely a different economy of scale, a different saving. Okay? And here you can see how the operators are using this right from the equipment. They are having a look at what's going on in the set parameters that I mentioned before and seeing if the process is working properly or if there's an alert, anything that they need to address. So this is immediate condition monitoring. This is also in the control room. So this is replicated in the central engineering in Italy or here in Germany are looking. The equipment that we're seeing on top left is in Brazil, and they can support also when there is complex situation to say, please go there, adjust this, collaborate there, make sure that you bring your maintenance or process engineer will resolve that. And of course, all of these solutions are scalable across the organization. Data-driven solutions, architecture, infrastructure, and value chain. And this is done with partners, guys. In this case, we weren't able to build our own scalable architecture, so we needed to partner with people that had the domain thirst and the data science competencies, the analytics, the deep machine learning analysis. And we went there and said, this is what we want to have. And we started representing this not anymore theoretically, but practically into a cloud-based solution made to purpose, made to fit. Now, something I need to say here. Of course, if you have the right partner where you don't have those competencies, it's a collaborative solution. It's one team. We utilize this now in our operations in steel and aluminum wheel manufacturing, but the same principles apply to fast moving consumer goods because you're manufacturing. They apply to pharma. They apply to other types of manufacturing. You have a process from where you collect data. You have a set of parameters from an equipment that replicates that process, and you have a product. So when you use that agnostic, saying this is steel, this is aluminum, this is pharma, this is food, you always have those parameters. As long as you're able to collect that data from those parameters in a structured way and feed it to an analytics platform, you will always be able to get benefits out of that analysis where the correlations are made and where the AI can tell you your most relevant variables to impact your manufacturing process are those ones. Let's have a look at them. I analyze the ones that give you an okay and the ones that give you a bad one. Let's avoid the ones that give you a bad one. Let's focus on those ones that give you a good one. And with that, if you guys are okay, and very quickly, maybe 2-3 minutes, Deepak, if you can give us a demo on how this looks in the platform so that we have some time also for the Q&A, that would be fantastic. Okay, I'll just drop out from sharing.
Sure, Esteban. Let me see. Yes.
Let me read also in the meantime the questions that I've seen in the.
Yeah. One second. Okay, is my screen visible?
Yes, sir.
Okay, thank you. So I'll just very briefly show the product demo. The product demo consists of, as Esteban mentioned, the bigger challenge here was ability to achieve AI and advanced analytics at scale. Maxion has so many product combinations, mold combinations. The sheer amount of data is literally very huge. So to implement this, and also Esteban rightly mentioned that the goal was to ensure that we are implementing usable AI or usable analytics. So to make that goal possible, we collect the data across all the machines for a specific use case. What I'm showing is a quality use case, which allows shop floor engineers to see their scrap rate in real time, understand or get alerted for any kind of deviations that are happening in real time, perform root cause analysis on various recipes for different products. You can see almost there are so many products which are lined up. You can basically, as a user, I can go back to 6 months, 1 year, 5 years of data and see how a particular wheel type has performed. What are the, or even in, let's say, last 1 day or 2 days, is my what is my scrap rate that is ongoing. I can also, for a historical type of data, I can also perform root cause analysis on the platform. I can see for a particular part number, what are the various runs, for how much time, whenever recipe was changed or not changed. There are also addressing scenarios where even if the recipes were not changed, why certain deviations occurred. Some of the very common questions which are regularly asked by process engineers can be answered here. Running root cause analysis, comparing two runs across two product runs, so that the process engineers are able to see what changed between two runs, and all that feature and the comparison is across all the features which can be created or have been created based on the process, and they're able to see whether which features deviated, which caused a higher scrap rate, or which caused a bad product to come out. Also, we have on the platform ability to generate recipes across all the products that have been manufactured, across all molds and so on. So a user can request that if a particular product has, let's say, 10,000, 30,000 parts manufactured, then what is the best recipe that I can use, considering the good and bad parts? What is the ideal recipe that I could use? I'll very quickly show the root cause analysis report, where for a particular product and mold, I can analyze if, let's say, my scrap rate is 8.33%, then I can analyze here on this report, and this reports get generated within few minutes, 1 to 2 minutes, depending on the amount of data. As a process engineer, I can analyze what was the difference between my good parts and my bad parts. Similarly, in other reports, I can very quickly, the platform provides me key insights on why a particular run of the same recipe at two different instances, why one performed better than the other. So same product, same mold, but one is producing a scrap rate of 10.3, the other is producing a scrap rate of 20, and it shows why that why these two differed and what was the root cause between one going ahead with a higher scrap rate, along with analytical data for somebody to look at even more deeply. And apart from that, the recipe generation part, where the sheer amount of data which the algorithm takes, let's say, for example, in this case, 36,000 parts, and it shows based on various scoring methods what is the ideal recipe. You can generate it. Clearly shows what are the various indices, scores, what are the top recipes, and you can download a recipe as well. And I think one of the questions which I saw, which I think Esteban will also answer, but alerting in real time, where the operators can take actions in real time for any deviations that happen, is also part of the solution, which takes into account all the data which is being captured. So I think I have really, in a very short time, tried to summarize the platform and demo. Esteban, let me know if you want me to go deeper, or we can hold on for questions.
Let's go to the question sessions there,
Yes.
because I think this is
Yes,
an
thank
overview.
you.
And yeah, let's go, Bob.
Yeah, thank you, Esteban and Deepak, for that.
Thanks, Deepak.
For that demonstration. Yeah, it's nice to see that we have quite a number of questions coming through. So let me get to those first. We have one from Mr. Shah, who says, is the AI platform able to take actions in real time to adjust process parameters for a batch, or is it post-analysis, or is it only for post-analysis? Can it do real time?
That's a great question, guys. And technically, the platform, if we connect it to the PLCs or the SCADA system, will be able to take actions directly. But we haven't enabled that feature at the moment because we need to validate with the process experts and the process engineers the prescriptions. And this is also their job to ensure that the value parameters are being prescribed. Remember, you have analytics, then you have predictive analytics, where it predicts what the outcome will be. In this case, we're talking really about prescriptive analytics, where the machine learning system tells you, change your process parameters to this process parameters. And this is where the human in the loop comes in, and the process engineer goes, okay, I've seen 5 propositions. This one has the highest score. Let me take that one there and adjust my process. So there is a human in the loop. Technically, that could be automated. We're not doing this at the moment because we're still maturing and growing both the process engineers and the platform on the adoption, right?
Right. Esteban, you also talked about the importance of partnerships in your presentation, and the IA platform was built by Tivaric, this company. So it was a conscious decision not to build something yourself within Maxion, but to look outside for that capability?
Correct. And that's a very good question, Bob. You know, our expertise is in manufacturing. We literally make the best wheels there is in the world at the moment. I mean, Ferrari takes our wheels, BMW, Mercedes. And it's not just for the look of the wheel, but it's because of the mechanical properties, the engineering of that product, that they match with those requirements. But we're not innate data scientists. We're not innate AI engineers. So if we wanted to really move fast and scale fast, we needed to identify partners that had that competency, that wanted to work with this industry, that we could then come together and say, hey, this is what we want to do. Are you able to do that? And this is how we ended up with a strategic partnership with Claudia, where they said, we can do the science. Let us know where we can apply it. And this is what we gave.
But having said that, did you also have to increase the level of knowledge and skills about AI within Maxion itself? Not becoming experts, but at least having a greater understanding of what AI can do and how to interpret.
Excellent question. Yeah. Excellent question. Everything, guys, you need to remember, is done by people, right? So the technology by itself is not possible if there's not people behind it, understanding and addressing and supporting it. We created what we call the Digital Academy, and we launched courses on each one of the focus areas, be it from connectivity, SCADA, AI, analytics, etc. And we train our teams not only on the basics, now also on the utilization of the platform, same as you would train on an SAP, or you would train on a PLM or a CAD. We train the impacted employees on how to address that as well.
Okay, thank you, Esteban. A couple of questions we have about data specifically. One is, how did you overcome the challenges of inconsistent data across, you have a wide number of plants across the world, the inconsistent data, but also, I'll take this question as well at the same time, how do you take care of and deal with the data quality as well? So data quality and inconsistent data across different plants.
Yes, again, excellent question. It took us a while to understand what was the relevant data parameters. So we had our data engineers and our shop floor operations teams to look into which were the necessary tags from the equipment that we needed to collect regarding the process. And then we started structuring that data. So before we actually feed that data into the platform, we structure it so that it's structured data. And together with the Tari team, we started identifying which were the right tags, the process values that we needed to collect. And we then made sure that those were properly communicated, identified as what they were, if it was temperature, pressure, cycle time, all of that properly identified to the equipment and to the timestamp. So once that structure was homogeneous and identifiable, only then we will share it with the cloud. And it took iterations, right? We're talking also different PLCs. Remember, different PLCs might have different programming languages. We needed to extract the right tags from different PLCs. I mentioned a few times about heterogeneous operations. So we needed to, some equipment is water cooled, some equipment is air cooled, some has water and air cooling. Some of them have Honeywell PLC, some of them have Siemens PLC. So we needed to make sure that we structured the data no matter what the equipment PLC was coming from in a way that the platform could consume it.
Okay, thank you. So essentially, you have been opening up and connecting the plant floor, and this question comes in from Daniel Ehrenreich, and he asks, "What about cybersecurity? Why didn't you mention cybersecurity in your presentation?"
That's a very good question. We take care of cybersecurity. We have segregated networks, and we have specific solutions that monitor anomalies in the shop floor. So I created a few years back what I call the production IT. So anything that connects to our network, we have also firewalls that separate the shop floor from the office environment. So we are addressing this. Now that at that time, function that I built called production IT has been upgraded to what we call digital factory, and that looks at not just the digital shop floor solutions that we deploy, but it looks also at OT security in our environment. So this is a focus point for sure.
Sure. Okay. Okay. Another partnership you mentioned, Esteban, was with AWS, Amazon Web Services, and this question is about how do you optimize cloud cost in a multi-cloud environment? Data egress cost. Yeah.
This is an interesting question. Natively, we are with Azure, Microsoft, because we're an O365 environment. But when it goes to scalable IoT and advanced analytical solutions, AWS is truly more capable, right? They are more affine, and they started much earlier in this journey than Google or Azure. So we balance specific solutions to specific partners and hyperscalers, right? So we went and did a benchmark, and that benchmark gave us clarity that before even, to be clear, adopting the solution that we saw, we started with AWS, and by coincidence, but more than by coincidence, by affinity and technology capabilities, Tuarit is also in AWS. And this is how we came together as well, saying, compatible solutions. Not only, guys, but AWS has identified this solution as a unique market proposition. So they also support us. They wanted to have us, and they helped us bring this up in our environment. And this is what we're doing at the moment.
Okay. I think this is a very good and relevant question because you talked quite a bit about having domain experts within Maxion Wheels. And this question is really about to what extent are the solutions that are provided by the new AI platform, are they taken seriously by those engineers, or perhaps was there a level of fear amongst those engineers that this is going to take over their expertise? What your response?
To any solution, change management is a key enabler, right? In some cases, they said, what is this machine telling me? I don't understand, right? Because in some cases, it prescribed some values that were not natural to the process of adjusting in the equipment. And they said, why would that work and not what we're doing? So yes, there is gaining trust. You need to be there, monitor, and you need to demonstrate the difference between what has been done conventionally with what's done aided by technology. And this change management requires a lot of attention. So if you ignore this part, you're not likely to succeed. Now there is companies, operations that we have that swear by it. They would never depart from it. They said, why didn't I do this before? Right? Because now they visualize the data, they understand what is happening in a visual way, in a tangible way, and they see the results at the end. But it takes, adoption. It really takes time.
Right. I see we are getting to the close of this session. Wow, 60 minutes has gone by pretty fast. So a couple of closing questions for you. As I said in my introduction, many companies start digital transformation efforts, but these are not able to be sustained over the longer term. So you talked about starting in 2018, and now it's 2025. How did you keep that going? What kept that from being one of those just a pilot project, but it's really gone 7, 8 years now? So
Yes.
what was your secret of your success in that respect?
Well, It truly takes engagement at all levels, right? So we have executive sponsorship. Then we were able to demonstrate ROI in implementing this. And we see now the results. And by doing so, it started as a push initiative, right? We needed to do this and we needed to demonstrate adoption and what that would mean. And slowly, that push went into a pull, meaning that, there is a clear ROI. We saw it with the energy and utilities analytic, how much we were able to actually reduce energy and utility consumption. We saw it also in the scrap reduction and productivity. So it's clear that adopting the right technologies will improve your operational efficiency. Once you can demonstrate that and you can scale that, then it's not anymore an if, but a when. When can we have it, right? Of course, you need to, and this is really important, the TCO, right? Because it's not just what you invest in your people time and the platform time or cost, but you need to enable also the data readiness. And this, in any case, is a must that needs to be addressed, right? Shop floor connectivity, PLC connectivity, equipment that might not have the right PLCs, you need to put sensors. But when you begin to understand what data can actually tell you about what you're doing and the value behind it, then this is an adoption that begins to scale up.
Yeah, okay. And when you were with us back in 2021, I mean, digital transformation was the hot topic in the industry. 4 years later, the hot topic now is artificial intelligence, industrial AI. So what advice would you give to someone in our audience, perhaps who's embarking on an AI project similar to yours in manufacturing? One piece of advice you could give them?
I would say, don't be afraid. Stay on it because it pays back, right? It really gives your ROI. Stick on it because when people begin to understand the capabilities and the opportunities, they will certainly would like to be part of it. And like I said to my executive, I say, is there an option not to do it? I mean, do we really not want to go in this direction? We all agree, yes, we want to. Of course, it needs to pay back and that you need to demonstrate. But if you can demonstrate that, then you have your road clear.
Right. Okay. I think that's a great piece of advice. So with that, I want to give my own thanks to Esteban for coming back to talk to us after more than 4 years. And it's really good to get an update and to see how far Maxion has gone since 2018. And now that you're going heavily into artificial intelligence and to give us your story on that as well. So maybe in 3 or 4 years, you can come back again and talk to us about your next stage of development.
Always a pleasure, Bob.
Yeah,
Always a pleasure.
Yeah. For now, we're not closing just yet. I'm going to hand back to my ARC colleague, Alina, who will do the final summary. Thank you.
Yes. Yeah. Thanks, Bob and Esteban. It was a great presentation. We have an announcement. The next DTC Digital Transformation Council Asia Online will be announced soon. And we have an upcoming event from ARC, that is in Tokyo, Japan. We have on 8th July. Bangalore event is scheduled on 10th and 11th July. And Singapore event is on 7th August. And recently we have completed our European Industry Forum and Annual Industry Forum of US America. So we would like to thank Esteban Ramek, CIO, VP Information of Technology and Digital, Yoshpe Maxion and Maxion Wheels for participating in this DTC Asia Best Practices webinar. We also thank Bob Gill from ARC Advisory Group for moderating this session. And we also like to thank all the delegates for participating in this webinar. So finally, we thank ARC Advisory Group India team for logistic support. Thank you all once again. Thank you.
Thank you, team. Have a great day.